My dear students, let me welcome you to the General Revision edition of Physics. In this edition, you'll be encountered with miscellaneous questions. The questions will be of gradual increasing difficulty. Hopefully, you'll find them interesting and beneficial. So let's get started. Now we've got mention an application of each of the following. We want an application, of mutual induction, of course, transformer, and induction coil, room curve coil. We call it induction coil. Okay, so an application of mutual induction is the transformer or the induction coil. Application of self-induction, it is the fluorescent lamp. Okay. Application of dual nature of electrons, it is the electron microscope. Electron microscope is based on the dual nature of electrons. Electrons can behave as particles and waves. Application of eddy currents, it is, induction furnaces. Application of spontaneous emission, it is normal light sources or traditional sources of light. Traditional sources of light based on spontaneous emission. Application of stimulated emission is the, laser, of course. Application of photoelectric effect, it is quite simple. It is photoelectric cell or photocell. Application of electromagnetic induction, it is the dynamo. And application or applications of the magnetic torque or magnetic effect of the electric current, we've got many devices: moving coil galvanometer, DC ammeter, DC voltmeter, and DC motors. So motor, moving coil galvanometer, ammeter, voltmeter, ohmmeter, they are all based on magnetic torque. Device based on thermionic emission or an application of thermionic emission, it is cathode ray tube. Device based on thermal effect of the electric current, it is the hot wire ammeter. And now we've got another type of questions. What is the scientific idea on which the function of each of the following devices based? Logic gates. What about the idea of logic gates? Okay, performing logic operations. So they are based on performing logic operations such as inversion, it happens in NOT gate, simultaneity or coincidence in the AND gate, and optionality in the OR gate. Okay, what is the idea of the extrinsic semiconductors? This is very important. Extrinsic means they've got, impurities. They are doped with the impurities. The conductivity of, this is the idea, conductivity of a semiconductor is increased when doped with certain impurities. The impurities increase the number of charge carriers in the semiconductor. Idea of the holography. Hologram is based on the idea that the reference beam, which is coherent and monochromatic, interferes with the object beam. So the difference in phase between the rays coming from the object as well as the difference in intensity are recorded on the holographic plate, and a three-dimensional image is obtained. What is the idea of the diode or PN junction as a rectifier? This is very important. The PN junction, the diode, permits the passage of the AC current during the halves in which the diode is forward biased and prevents its passage during the opposite bias. Idea of the transistor as a binary device. The circuit of a transistor can have two states, off or on, so it can be used as a binary device. As I said, a binary system is a digital system based on two digits. The digits are 0 and 1. And now we've got another sort of questions. An AC supply of variable frequency is connected each at a time to the following: pure inductor, pure capacitor, non-inductive ohmic resistance. What happens to the maximum current that flows in each circuit when the frequency is doubled? Okay, so we'll take it one by one. In case of the pure inductor, how to calculate the maximum current? I maximum equals V maximum over XL. XL is the inductive reactance. V maximum equals NAB 2 pi F, NAB omega, XL equals 2 pi FL. So frequency will be cancelled out. So it is just NAB over L. So maximum current is independent of the frequency. It is independent of the frequency, so it remains unchanged. And what about the capacitor? In case of the capacitor, what happens? Maximum current is determined from the relation V maximum over XC. So it is NAB 2 pi F, XC equals 1 over 2 pi FC. So I maximum will be equal to NAB 4C pi squared frequency squared. So I maximum is directly proportional to square the frequency. So when the frequency is doubled, maximum current is made 4 times greater. Okay? So if I maximum is made 4 times greater when the frequency is doubled. And finally, what about the non-inductive resistor? I maximum equals V maximum over R. It is NAB 2 pi F over R. So maximum current is directly proportional to the frequency. So when the frequency, yes, increases, maximum current increases. If it is doubled, the current will be doubled. So I maximum is doubled when the frequency is doubled. Mention one use of each of the following. We want one use of laser light in medicine. Okay. Laser can be used as cutting or welding tool in delicate eye surgery. One use of laser in military field. Laser has military applications such as aiming and guidance of missiles and smart bombs. Aiming and guidance of missiles and smart bombs. One use of X-rays in industry. X-rays are used to check defects in metallic structure because X-rays have high penetration power. They have high penetrating powers. One use of laser in industry. High-powered pulsed lasers are used in metalworking for welding, cutting, and for piercing holes. Okay, another question. What is the logic gate which has only one input? It's all easy. It is the NOT gate. Okay. What is the logic gate which inverts the input voltage such that a high input voltage gives a low output voltage and vice versa? Also, it is not gate. What is the logic gate which has two inputs and the output is high only if either of its inputs is high? Okay, it is the OR gate. What is the logic gate which has a low output voltage if only one of its inputs is low? Okay, it is also it is AND gate. Okay. And now we've got a problem in front of you. We've got energy levels. The figure shows some possible transitions for the electron of a hydrogen atom. Which transition gives the photon that lies in the infrared region? Infrared region. Okay, it's all easy. It must be line C. Okay. And which transition gives the photon with the highest energy? Highest energy means highest frequency and smallest wavelength. It must be line A. And what is the name of the series that line B belongs to? Line B, okay, here the electron relaxes to n, which is equal to 2. So it is Balmer's. It is the visible one. Okay, it is Palmer series. Another type of questions, it is about the transistor. Okay, use the figure shown in front of you to answer the following questions. What is the type of the transistor shown in the figure? Okay, you can determine the type of the transistor from the arrow on the emitter. So it must be NPN transistor. It is NPN transistor. Okay, what is the state of the transistor? Is it on or off? It is shown in front of you that the base is connected to the positive terminal. So it is on state. So talking about the state, it is on state. What is the value of VC, voltage across the collector, if the current gain beta E is given to be equal to 49 and the emitter current is 150 milliampere? Beta E equals 49. Emitter current equals 150 milliampere. Current gain is given, yes, by the relation alpha E over 1 minus alpha E. Current gain equals 49 equals alpha E over 1 minus alpha E. So alpha E must be equal to 0.98. And alpha E equals IC over IE, current collector over current emitter. So 0.98 equals IC over emitter current is given, and this way we managed to obtain the current flowing through the collector. It is equal to 0.147 ampere. We managed to obtain the collector current, so we can obtain the voltage across the collector. It is ICRC. VC equals ICRC, so it is 0.147 times 10, it is 1.47 volt. And VCE is the difference between, yes, the 6 volt battery and VC. So 6 minus 1.47, it is 4.53 volt. write the scientific term. The magnetic flux which induces an EMF of 1 volt in a single turn coil, when the flux is reduced, flux through the coil is reduced to 0 in 1 second. What is the scientific term? Okay, it is the Weber. Okay. Magnetic flux density of a uniform magnetic field which produces a force of 1 Newton on a wire 1 meter in length, carrying a current of 1 ampere when the wire is placed perpendicular to the field. Magnetic flux density, okay, which produces a force of 1 Newton on a wire 1 meter in length, carrying a current of 1 ampere, and the wire is placed perpendicular to the field. Of course, it is the Tesla. The instantaneous EMF, instantaneous electromotive force induced in the coil of an AC dynamo when the plane of the coil, okay, makes an angle 45 with the field. What about this instantaneous EMF? It will be equal to the, yes, thank you very much, effective value. It is the effective value of the induced EMF. The resistance of a wire, 1 meter in length, the wire is 1 meter in length, having a cross-sectional area 1 meter squared at 20 Celsius is 1.7 times 10 to the power of -8 ohm. Okay, what do you understand from this? Okay, so resistivity must be equal to 1.7 times 10 to the power of -8 ohm meter. Resistivity of the material of that wire at the mentioned temperature is 1.7 times 10 to the power of -8 ohm meter. The torque exerted on the coil. Torque exerted on a coil when the coil is placed such that its plane is parallel to a magnetic field of density 1 Tesla, the torque is equal to 0.08 Newton meter. Okay, so magnetic dipole moment, okay, of the coil is 0.08 ampere meter squared. Scientific term, okay, an EMF of 2 millivolt is induced in a coil when the current changes in the coil at a rate of 1 ampere per second. EMF of 2 millivolt, so inductance is equal to 2 millihenry. Ratio of the electric power or electric energy produced in the secondary coil to the electric power consumed in the primary coil of a transformer is 0.9. Ratio between the two powers, produced power and consumed power. It is efficiency. Okay. So efficiency of the transformer is 90%. We can say, okay, efficiency of course equals VSIS over VPIP, and it is 90%. Scientific term, the direct current that produces the same heating effect per second as that produced by an alternating current is 10 amperes. Direct current which produces same thermal effect per second is the effective value. Effective value of the AC current is 10 amperes. The rule which determines the direction of the current induced in a coil, the moment the field through the coil, the moment the field that intercepts the coil changes. Okay, which rule is used to determine direction of the induced current in a coil? It is Lenz's rule. And now we've got another type of questions. What happens when? What happens when the two metallic rings in an AC dynamo are replaced with a split cylinder commutator? Two metallic rings are replaced with, yes, a commutator. The current, it changes from AC current into, yes, unidirectional pulsating current. So the AC current becomes unidirection varying current. What happens when the shunt in an ammeter is replaced with another of lower resistance? Okay, with respect to the sensitivity of the ammeter and the maximum current that the ammeter can measure. Okay, what happens to the sensitivity if the shunt is replaced with another, okay, of lower resistance? Sensitivity decreases, and this means the meter can read greater currents. What will happen to the reading on the hot wire ammeter in the opposite circuit when the key is closed? Okay, when the key is closed, what happens? Yes, we are connecting the second capacitor, and they are connected in parallel. So the capacitance will be increased, and when the capacitance increases, reactance of the coils decreases. So the current, yes, increases. So once again, since the capacity of the capacitors increases when connected in parallel, okay, so the capacitive reactance decreases and the current increases. So reading on the ammeter will be increased. Okay, what will happen to the reading on the voltmeter in the circuit shown in front of you when the value of the variable resistance is increased? Your attention please. Here the voltmeter reads the voltage across, yes, the resistance R. Okay, it is designed to measure the voltage across only R, the external resistance here. Okay, what about the voltage applied across this resistance? It is the product of the current and the resistance. The resistance is constant, so the current will determine what will happen to the reading of the voltmeter. When increasing the value of the variable resistance, the current decreases, so reading will be decreased. Okay, so the reading on the voltmeter decreases. Your attention please. Voltmeter here in this particular case reads the voltage only on the resistance R. What happens when the key in the circuit shown in front of you is opened? We've got neon lamp placed, connected across electromagnet. What happens? Yes, the lamp momentarily flashes. Okay, we want you to justify your answer. So the answer is the lamp momentarily flashes due to the high forward EMF induced by self-induction. What happens when the switch in the circuit is closed? Okay, your attention, of course, with respect to the readings on the two voltmeters, V1 and V2. Now, right now, before closing the switch, V1 reads, yes, the value is maximum and reads EMF of the voltage. V2 reads 0. So what will happen when closing? V1 will be decreased. It will be, instead of EMF of the cell, it will be just the terminal voltage. And since current will flow, so V2 will be increased. V1 decreases, but V2, yes, increases. V1 decreases, V2 increases. Okay, we want you, of course, to say what will happen to the readings of the 2 voltmeters. So, V1 decreases, but V2 increases. In this way, we've come to the end of the edition. Thank you for watching. All the best and goodbye.